In this video, we want to look at one of the key experiments in the development of the atomic model, and that experiment was conducted by J.J. Thomson. In his experiment, he used something called a cathode ray tube. And here you see a sketch of cathode ray tube. So you have this oblong, cylindrically shaped piece of glass. You see at either end embedded into it are discs made out of some kind of metal. So they conduct electricity, so they're called electrodes. So there's an electrode to the left side and to the right side. You can see in this case that there are wires hooked up to those electrodes leading back to a variable voltage source. Looks like a battery. You can see it's got a positive and negative charge. The little arrow tells you that I can alter the voltage, so I can change how strong of a voltage is going to be applied across those electrodes. And so one electrode is attached to the negative side of the battery, and it's going to have a negative charge on it, and one side is connected to the positive side of the battery, and it's going to have a positive charge. So if I go ahead and flip the switch, we would see a beam shoot across the center. And many other scientists before JJ had kind of played around with the cathode ray tube, and they would have observed the same sort of thing. And the thought was that this beam was traveling from the left side to the right side. It was traveling from the negative plate to the positive plate. And that's what JJ discovered, that it indeed does flow from negative to positive. Now we have special names for these electrodes. The one that is got a negative charge is called the cathode. That's why this is called the cathode ray tube, because the ray is coming off the cathode. And the positive plate is called the anode. So those are special names for electrodes based on their charge. Now JJ went along and he did something different with his cathode ray tube. He brought in a magnet. And here you see it depicted as a bar magnet. You see the typical north and south pole that magnets have. And he was trying to discover what exactly is this beam made of. And when he brought his magnet nearby, he noticed that the beam didn't stay going straight across the center of the cathode ray tube. And if you understood a little more physics and knew a little more about electronics and magnetism, depending on which pole, whether you bring the north or south pole near the beam, that causes our cathode ray to either be attracted and be moved upward, or be repelled or pushed downward, as you see in my diagram here. Well, JJ knew a lot about electronics and magnetism, and by the way the beam interacted with the magnet, he knew that that beam was in fact made up of negative particles. And so this cathode ray is actually made up of negative particles, and JJ decided to call these negative particles, he called them electrons. And through other parts of his experiment, he actually was able to figure out that these particles, these electrons that were newly discovered, were lighter, 2,000 times lighter than the lightest atom known at that point in time, which was the hydrogen atom. So he knew these particles were smaller than atoms. And so this is the discovery of the first subatomic particle, the electron. As a result of the discovery of the electron, JJ knew that the model that Democritus had come up with for the atom could not be true. So he modifies it and comes up with his own model, which is referred to as the plum pudding model. Now, just to give you an idea of what that cathode ray tube really looks like, here's a photograph of one. You can see the wires leading off of the cathode and the anode, and you can see the cathode ray going down the center. That plum pudding model, then, is based upon knowing that positive and negative charges are present. And JJ pictured that the atom itself was sort of a cloud and that it had a positive charge. Here you see it depicted in gray. And that these new particles he discovered, the electron, they were arrayed evenly throughout this positive cloud. And so you have this even distribution, even mixing of positive and negative charges, and hence this is called the plum pudding model. Maybe a fancier diagram that I found for you depicting the same thing. Here's a plum pudding model of the atom. So we've altered what we picture an atom looking like, and it's based upon experimental evidence.